All right, welcome back to Math with Miss Lastly. Hey guys, hey. This is our last video. So if you have been hating these, we're almost done. If you've been loving them, we're still almost done. So sorry about it. Anyways, so today we are going to be looking at determining which quadrant we're in based on some given information. We've kind of done some of these things before, but we're going to just touch up on it again. And then we're also going to use the information that we have in the quadrant that we're in to find some trig ratios, setting up, our sine, cosine, tangent, cosecant, secant, cosecant, all that fun stuff. And then we're also going to be finding the reference angle and the actual rotation angle of our reference triangles that we're dealing with, our angle theta. So let's do it. All right, so you should again have your guided notes in front of you. We are on notes day number 6, quadrants and ratios. So the first thing we're going to take a look at is just positives and negatives. All right, not of the class, just of angles, okay? So positive versus negative. Okay, we're gonna kind of take it back to the basics here. So this is, again, I had to plug it in because it was dying. There we go, sorry. It doesn't like to be plugged in and written on at the same time. It's really picky. So this is quadrant 1. All right, x is positive and y is positive. All right, now since x is positive, we know that cosine is positive. Okay, so remember we aligned cosine with our x-coordinate. That is true. Now that's not just true in the unit circle, that is true in all circles. It's just the cosine value of all circles is going to be x over the hypotenuse, which we know the hypotenuse is always positive. So it doesn't really affect the positive or negative sign of our angles. Or our x value, sorry. All right, so no matter what the hypotenuse is, cosine still takes the positive negative sign of the x coordinate. So in quadrant 1, since x is positive, cosine is positive. Since y is positive, that means sine is positive. Now our ratio, so if we were to do y over x, since y over x is positive, because both x and y are positive, that means that, so this is positive, which means that tangent is positive. Now, I know I didn't write the reciprocals, but they do follow along the same pattern as their parent, not really parent, but their reciprocal, right? So cosine is positive, secant is also positive. Sine is positive, so cosecant is positive, and cotangent is also positive. So quadrant 1, literally everything is positive. All right, so moving into quadrant 2. Now stuff starts to get a little bit more complicated. So quadrant 2. All right, in quadrant 2, so let's just box up our quadrants. So this is quad 1. I don't know why I wrote it over on the side. It doesn't really matter. It's late. We're now at 11:30 p.m., so it's late. All right, so in this quadrant, x is negative, which means cosine is negative, which also means secant is negative. I'm not writing it. Just know that cosine and secant go together, sine, cosecant go together, tangent, cotangent go together. You don't need to think of them separately except their values, right? But really their values aren't that separate. They're just reciprocals of each other, all right? So x is negative, therefore cosine is negative. All right, in second quadrant, y is positive, so sine is positive. All right, so y over x, all right, since x is negative and y is positive, this is going to be a negative value, which means tangent is negative. There's quadrant 2. Quadrant 3. Quad 1, 2, 3. Box it up. There we are. All right, so in quadrant 3, x is definitely negative. Therefore, cosine is negative. Y is also negative, so sine is negative. And the fraction y over x, so since we have a negative divided by a negative, this actually is going to be positive, which means tangent is positive. All right, and then last but not least, we have quadrant 4. So quad 4. All right, in quadrant 4, x is positive, right? So we're on the positive x-axis here, which means that cosine is positive. However, y is negative, so sine is negative. And then our fraction, y divided by x, so since y is negative, x is positive, this is going to be a negative value, which means tangent is negative. Now, I know it seems like a lot to remember, but there is an acronym, I think that's what they're called, all right, that will help you. So A, S, T, C. All things are positive. S, just sine is positive. T, just tangent is positive. C, just cosine. All right, and it's all students take calculus. All students take calculus. A, S, T, C. All right, and so that's going to tell you what's positive. So quadrant 1, everything is positive. Quadrant 2, just sine is positive. Quadrant 3, just tangent. Quadrant 4, just cosine. All right, so hopefully that will help. All right, and then another thing, just because I want to put it on here, because I don't know, it's important, right? Just a reminder, this is 0 degrees, this is 90 or pi over 2, this is 180, which is also pi, this is 270, which is 3 pi over 2, and then this is 360 or 2 pi. All right, so now we're going to be doing some reference triangle work and applying it to our coordinate plane and things like that. So here we go. Step by step. All right, I'm just going to go through step by step how you should be doing these, what piece should come first. All right, I know one of the hardest parts in math is just knowing where to start and what to do. So if I give you a checklist, my hope is that you can follow the checklist and do well. All right, so first thing we want to do when we're attacking any of these problems where they have like given us some information and they want us to kind of fill in the blanks of like the problem. That's essentially what these are. They've given you pieces and they want you to find the rest of it. All right, you're going to use your ratio. So use the ratio that you're given to narrow down which quadrant it's in. Narrow down quadrant to 2 options. All right, so we're going to pause because it's not writing right now and I want to let it catch up. I'm going to see what's happening because I don't know at this point. So we're going to pause. All right, it worked. No idea what happened. In case you're wondering, like 7 minutes just passed. So you're welcome for pausing because that was boring. I don't even know what happened, but it decided to work again. So here we are. All right, so use the ratio that you're given to narrow down your quadrant to 2 options. All right, so whatever ratio they give you, it's only going to narrow you down to 50-50, right? Because if you look at our XY axis, right? For instance, cosine being negative, there are two quadrants where cosine is negative, but you can at least narrow it down to quadrants 2 or 3. All right, so that's what your first step is going to do. So use whatever ratio they gave you to narrow down to 2 quadrants. All right, your second step is going to be to use whether they gave you an interval or they gave you an inequality as the second piece of information. You're going to use that to figure out the ultimate quadrant that you're going to be in. So you're going to take that 50-50 and you're going to narrow it down to the exact value. All right, so step number 2. All right, use the inequality. Use inequality or interval. Sometimes they might give you an interval, right? So just a reminder, inequality would be something like x is greater than 0. An interval would be 0 to infinity, right? That's the difference, just in case you had maybe forgotten, right? So use inequality or interval to determine the quadrant. Kind of based on step 1, right? So using step 1. Cool. Step number 3. Sketch and label. That says label. We're going to try again. All right. Step number 4 is to find any missing sides that you have in your problem. So you should be missing one side. All right, so find the missing side. Plugged it in, and now it's doing this awful stuff. It doesn't like to be plugged in. All right, so find missing side. Use that to find the indicated ratios. To find indicated ratios. All right. So you're going to find your missing side and then you're going to use it, essentially, right? So the problem is going to say, like, I don't know, for instance, cosecant of theta is negative 15 over 7. And then, I don't know, this is good. We're going to make these up as we go. That's fine. They're examples. I didn't even tell you what ratio you were looking for. So you would find the ratio that they tell you to look for. And we're going to make it up for these because I left it off and I've already printed these guided notes. So you're going to have to add it to your page too. I'm not reprinting them because it was a billion and I wasted too many trees already for this whole sub situation. Okay, so anyways, you're going to use your missing side to set up the ratio that they want you to set up. All right, and then step 5, so this is where our reference angle piece comes in. So step 5 is going to be to find the reference angle. Using any ratio, any of the ratios, using any ratio you want. Sine, cosine, tangent. If you want to do the reciprocals, you can. You'll notice that your calculator doesn't have a button for the reciprocal functions, but remember it's 1 over sine or 1 over cosine, so that's how you would have to put them into the calculator. So there's that. But you can use those if you want to. I wouldn't recommend it though. All right, so find the reference angle using any ratio, and then use that to find the actual angle of your terminal side. All right, so use reference angle to find rotation of your terminal side. Now, I will say that when we are finding our angles here, like our using the reference angle to find the rotation of our terminal side, we are assuming that our terminal side has been rotated counterclockwise. So unless specified, you are looking for the positive rotated angle that is only done less than one rotation. So we don't want any angles that are larger than 180. There are infinitely many angles that would share this reference angle and be in the same quadrant. So we're just looking for the positive closest angle, all right, to that reference angle. So we should be less than 360, but greater than 0. All right, so here we go. I am going to finish making these problems really quick. So for the first one, let's say we want to find cosine theta and cosecant. No, we already got cosecant. Cosine and tangent, sure. And then we want to find our theta. I'm just going to put theta because that's our angle name. And then for this one, let's do sine and secant. And we're going to find our theta. Cool. So that's what we're going to do for these problems. So add that piece because that's part of the problem that I just left off. Not intentionally, I just forgot that I didn't write it all. I don't know. Somebody probably was asking me a question and I got distracted. Happens all the time. I'm going to make it a little smaller because it's taking up too much of my space. Ta-da. Okay. So I'm also going to like divide these because I don't want to like have one run into the other. There we go. That's just a personal preference thing. That's why I usually use tables. It doesn't matter. It doesn't matter. Okay. So first off, we're going to use our clues. So the first thing they tell me is that cosecant is negative. Cosecant is negative when sine is negative, which only happens in quadrants 3 and 4. So I know that I am either in quad 3 or 4. All right, that's based on the cosecant piece. Next, it tells me cosine theta is positive. Cosine is only positive in quadrants 1 and 2. So cosine is positive only in quadrants 1, not 1 and 2, 1 and 4. So we are looking for the overlap, which is quadrant 4. All right, so that means that I must be in quadrant 4. So I'm going to go ahead and sketch my triangle. All right, and here I am in the 4th quadrant. Boop-a-doo-boo. Here is my reference angle. It's not really, I'm not going to use theta because this is not really theta. This is just our reference angle. So you can put theta there if you want to. Just know that theta is actually this angle right here, right? So that's theta, all right? So it's our reference angle is not theta. It is what we are using to set up our ratios, but it is not our rotation angle for our terminal side. So just keep that in mind. Okay, so we are now going to use the ratio they gave me, which was cosecant, to set up this triangle. All right, cosecant is hypotenuse over opposite. So my hypotenuse is going to be 15 and my opposite is going to be -7. All right, if you are wondering how I knew that the 7 was what was negative, that's because the hypotenuse can never be negative. All right, so it has to be my opposite side. I also know that that side is going to be negative because I'm in quadrant 4 and that is a negative y value. All right, so next up is Pythagorean theorem to find my missing side. So 15 squared minus -7 squared. I don't think this is one of the triples, so 176. So this is going to be x squared, right? So I got 176 And that then as a square root, and I just broke that down into 16 times 11, so that would be 4 root 11 for my x value. And it's positive because I'm along the positive x-axis, so 4 root 11. Awesome sauce. So next up, I'm going to go ahead and find my two indicated ratios. So I want to find my cosine value. So cosine is 4 root 11 over 15. Right, tangent, I'm going to do a little bit of work for because I need to simplify. So over here, I have negative 7 over 4 root 11. Rationalizing my denominator, negative 7 root 11 over 44. And that's my answer. So negative 7 root 11 over 44. All right. Now what I want to do is pick a ratio to use to solve my reference angle. And I'm going to pick the one with whole numbers in it. So I'm going to use sine. So sine is negative 7 over 15. So plugging this in, now I'm just going to plug in positive 7 over 15. If I plug in negative 7 over 15, it's going to give me a negative reference angle, which is fine. You would just change it to positive because reference angles are always positive. I'm just going to plug in a positive 7 over 15, so I don't even have to think about it. So inverse 7 over 15. And I got 27.8, so 28 degrees. So my reference angle is 28 degrees. All right, to find my actual angle, which is the angle on the outside, I'm going to take 360 and I'm going to subtract 28 degrees, right? Because if a full circle would be 360, I'm going 28 degrees less than that. So 360 minus 28, and that is 332. And that is my theta. Awesome. All right, so just a reminder, right? If this is in the quadrant 4, this quadrant is only degrees between 270 and 360. So 28 doesn't even make sense. That's a reference angle. Please don't just put 28. You get it wrong. You get no points for that. All right, because it's not the angle. It's just the reference. All right, now I gotta scroll sideways. Come back, come back. There we go. All right, so at this point, my recommendation is to pause the video and do this problem on your own. And then, I'm sorry. It's really late. All right, so pause the video, do the problem on your own, and then turn it back on, and then just use that to check your answers. So you try this one on your own. I'm going to sit here and I'm going to do it, and then you can check your answers when you're done. All right, so I just ran through that. I don't know how long it takes. It took. It's past my bedtime. All right. So I found out which quadrant I was in. I got it down to quadrant 3. All right. So tangent was positive in quadrants 1 or 3. And then my interval tells me that I'm between pi over 2 and 3 pi over 2. That's quadrants 2 and 3. So my overlap there would have to be quadrant 3. So I sketched my angle in quadrant 3. That means both my x and my y value are going to be negative. So I have a negative 4 and a negative 5. Finding my missing side, I get square root of 41. That cannot be simplified. So then I set up my ratios for sine theta. It was negative 5 over square root of 41. I rationalized my denominator. Secant, I didn't need to rationalize my denominator. The square root was already in the numerator, so it's just negative square root of 41 over 4. My reference angle, I used tangent because it had the whole numbers. I got a reference angle of 51 degrees. This angle is in quadrant 3, so I'm going 180 plus whatever my reference angle is. So I did 180 plus 51 and got 231 for my rotation angle for my terminal side. That is it for today, and that is actually our last video. Hope it was good. Hope you learned some stuff. Remember, if there are any questions that you have for me, please jot them down and then we can go over any of those questions on Monday. All right, have a good Thanksgiving break and I will see you all when we come back.